Today we're going to look at the metric system, and I know you've used the metric system about 1,000,000 times before, and you learn it every year for a couple of days and then you go and forget it. I'm hoping this year you will use it enough that you'll get used to it and it will kind of stick in your head. We'll look today at 3 different units of measurement and all the prefixes that go with them, and we're going to look at how to convert between the different units of measurement. So let's start with the 3 things that we might want to measure. We might want to measure length. And the base unit for length is a meter, and a meter is a little bit more than a yard. And we might want to measure volume, the amount of space something takes up. And we can use for that a cubic meter, which is really big, so we don't usually use that in chemistry. We might use a cubic centimeter. The other thing we can use if we're doing volume is, especially if we're measuring liquids, we can use a liter. And you're familiar with liters because soda is sold in 2-liter bottles, so it's about a quart. And then we can measure mass, the amount of matter in something. We already learned that when we learned density, and that is usually measured in grams. So let's look at the prefixes. What I especially want you to see is how the prefixes are related to the base units. So what we're going to say here is that, let's start with a big one, kilo. So the abbreviation for kilo is a K. And 1 meter, let's just use meters as an example. 1 meter is equal to 1/1000th of a kilometer. And now we're going to use units that make, we're going to use prefixes that make the unit smaller. So the first one is deci, abbreviated with a D, as you might expect. And 1 meter is equal to 10 decimeters. And then we can have centi, abbreviated with a C, and 1 meter is equal to 100 centimeters. And then we can have milli, abbreviated M, and 1 meter is equal to 1,000 millimeters. Now follow me here. If I wanted to substitute grams, I could say 1 gram is equal to 1/1000th kilogram. 1 gram is equal to 10 decigrams, and so forth. So I'm just using meters as an example. Okay, micro. And since we already used the M, we have to go to a Greek letter. This is called a mu. And so 1 meter is equal to 1,000,000 micrometers. Now at this point, it might be handy to start using the exponents for this. So this is 10 to the 6th. This is 10 to the 3rd. 10 to the 2nd, 10 to the 1st. If you remember those. Okay, a couple more. We've got nano, which is N. 1 meter equals 10 to the 9th nanometers. I'm not even going to write in all those zeros. That would be, by the way, 9 of them. And then pico, which we don't see very often at all. 1 meter is equal to 10 to the 12th picometers. So these are the equivalencies that we can use to solve problems with. So why don't you make sure you get those written down. Pause the video if you need to. I'm going to erase and start working a problem. So let's say that we want to take 250 centimeters and figure out how many meters that is. So what we already know from what we wrote down a minute ago is that 1 meter is equal to 100 centimeters. So if you're not comfortable just moving the decimal point around, and if you are comfortable, just feel totally fine about doing that. But I'm going to show you a ratio method that will help, I hope. So let's say that we take 1 meter and make a ratio. This ratio is always true. 1 meter is always equal to 100 centimeters. So we can set this up over here with x meters and 250 centimeters. So this ratio and this ratio have to be the same. We just don't know what number goes in here. But you can set this up as long as we have these two things from your list of equivalencies, and these are the same and these are the same in the same positions in the fraction. Then we can cross multiply. So x times 100 equals 250 times 1. And to solve, we're going to use some algebra and divide both sides by 100. So now I know that in order to find x, I have to take 250 and divide it by 100. So I can do that in my head by moving the decimal point 2 places to the left, which you may have already figured out without all this ratio business. Or you can put it on the calculator if you just want to check yourself. So 250 divided by 100 is 2.5 meters. So we have an answer. Now let's try another one where we have to go the other way, and we'll start with, let's say, grams. Let's start with 35 grams. And we want to figure out how many micrograms that might be. So what do I know? I look at my list of equivalencies and I say, well, I learned that 1 gram is equal to, oh, 1,000,000, or 10 to the 6 micrograms. All right, so if I want to set up a ratio, I could say that 10 to the 6 micrograms is equal to 1 gram. So this ratio will always be true, this ratio of micrograms to grams. I'm trying to find micrograms, so I can say x micrograms over here and 35 grams on the bottom. So again, remember that the micrograms, if they're going to be on the top, they have to be on the top on both fractions. But they don't have to be. You can flip this if you want and put grams on the top, but just make sure they're in the same position on both sides of the equal sign. All right, cross multiplying x times 1, oh, that's nice, is 35 times 10 to the 6. So at this point, it's a whole lot easier to just leave it in scientific notation. And if you remember how to do proper scientific notation, we want a decimal point right there. So we'll say 3.5 times 10 to the 7th. But since we haven't officially learned scientific notation yet, if you left it in that form, I would be okay with that. So we'll say 3.5 times 10 to the 7th. Now there's one more kind of problem that we might have to do where we don't actually have a base unit involved. Let's try one of those. Let's say that we have decimeters. Let's do that. 495 decimeters is equal to how many, where do we want to go from here? Nanometers. All right, so what do we know? We don't actually have an equivalency that gets us directly from decimeters to nanometers. So there's a couple of different ways we can approach this. One is just moving the decimal point around. So let's put down what we do know. We know that there's 10 decimeters in a meter, and we know that there's 10 to the 9th nanometers in a meter. So the difference here appears to be, this is 10 to the 1, do you remember? The difference here appears to be 8 decimal places. So I know that I'm going to have to move my decimal point 8 places in order to solve this problem, because that's the difference between a decimeter and a nanometer. Well, which direction would I have to move it? These are smaller than these, so I need more of them, so I'm going to have to move it to the right 8 places. So right now it's here, So we could say 495 times 10 to the 8th, which is really 4.95 times 10 to the 10th. All right, let's look how that would work out if we did it with the proportionalities. It would become a two-step problem, actually, because I know my decimeters, and I would have to go from there to meters, and then once I had meters, I could go from there to nanometers. So let's do that. And let's say I'm going to do this. 10 decimeters and 1 meter can go together because that's a ratio that we know. And so now I'll have 495 decimeters and x meters. Okay, so this time my x ended up on the bottom, and that's perfectly fine because we're going to cross multiply. So we'll say 10x is equal to 495 decimeters. Whoops, we don't care about decimeters right now. And I'll have to divide by 10 and divide that by 10. And so x equals 49.5. So that only gets me from decimeters to meters. Now I would need to do a second step to go from meters to nanometers. And now I'm going to use this. So I will say 10 to the 9th nanometers. I'll use that ratio, 10 to the 9th nanometers to 1 meter is x nanometers to 49.5 meters. Okay, so nanometers on the top, meters on the bottom, or vice versa, but they're in the same positions. So now I can finish this up by cross multiplying. So x times 1 is x, very convenient. And 49.5 times 10 to the 9th, which is not really proper scientific notation because I want the decimal point in that position. So x is 4.95 times 10 to the 10th, which is what we got up here. So either method should get you the same answer.